Dear children, today we are going to discuss about 8th standard science, 3rd term, unit 6, sound, part 3. For the previous video, we discussed sound introduction, production of a sound, propagation of a sound in the part 1 and part 2 videos. Sound propagates in the medium in the form of compressions and rarefactions. Sound is a form of energy. It is transferred through the air or any other medium in the form of mechanical waves. Characteristic of wave motion. For example, fill half of your trough with water and place some crumbled paper balls in it. Then make ripples on surface of water using fingers. The disturbance travels on the surface of water in concentric circles of ever increasing radius till they strike the boundary of the trough. Now the paper balls move up and down as the wave passes, but the ball do not travel along with the wave. Here, the water particles move up and down about their mean position without the displacement of propagation of a wave. From this example, we know clearly about the wave motion. Only the energy is transferred, not the particles. Number 2, the velocity of the wave motion is different from the velocity of the vibrating particle. Number 3, for the propagation of a mechanical wave, the medium must possess the properties of inertia, elasticity, uniform density, and minimum friction among the particles. Types of mechanical wave. There are two types of mechanical wave. They are number 1, transverse wave. Number 2, longitudinal wave. First we move to longitudinal wave. In a longitudinal wave, the particles of the medium vibrates in a direction which is parallel to the direction of propagation of the wave. Sound waves or longitudinal waves. Sound propagates the medium in the form of high pressure and low pressure regions. Hence the sound waves are also called pressure waves. Transverse waves. In a transverse wave, the particles of the medium vibrate at right angles to the direction of its propagation. Next, properties of a sound. All sounds we hear are not same. There are some properties that differentiate one kind of sound from another. So first we move to pitch. What is pitch? Pitch is the property of the sound that distinguishes shrill sound from a grave sound. So what is shrill sound and what is grave sound? Shrill sound means thin sound. Then shrill sound is produced when the frequency of a sound is high. For example, sound of woman, sound of birds, sound of cat. These are the examples for shrill sounds. Then another one is grave sound. What is grave sound? Grave sound means thick sound. Grave sound produces when the frequency is low. For example, sound of men, sound of dogs, sound of frog. Number 2, loudness. What is loudness? A sound depends on sound energy. When the sound energy is high, the loudness is also high. For example, consider two sound energy. One is quieter and another one is a louder sound. Which is responsible for quieter sound and which one is responsible for louder sound? It is because the amplitude of this sound is small while the amplitude of this sound is large. So the loudness of a sound depends on its amplitude. Number 3, quality or timbre. What is quality? It is also the property of the sound by which two sounds of the same loudness and pitch is distinguished. For example, consider sound 1 and sound 2. Let the sound 1 has frequency f is equal to 10 Hz, wavelength is equal to 0.01 meter and the amplitude is 0.02 meter. Also, the sound 2 has a frequency f2 is equal to 10 Hz, wavelength is equal to 0.01 meter and amplitude is equal to 0.02 meter. It means that these both sounds have same frequency, same wavelength and same amplitude. Now I place a sound 1 on a drone and sound 2 on a piano. Can you differentiate between sound 1 and sound 2? Well, the answer is yes. In this activity, we differentiate the quality of a sound. Next, we move to audibility and range. According to the frequency, we can classify the sounds into three types. They are audible sound, infrasonic sound, ultrasonic sound. Number 1, audible sound. Sound with the frequency ranging from 20 Hz to 20,000 Hz is called sonic sound or audible sound. Sound with this frequency range alone can be heard by the human beings. Human ears cannot hear the sounds with the frequencies below 20 Hz or above 20,000 Hz. So the above range is called as audible range of a sound. Number 2, infrasonic sound. A sound with a frequency below 20 Hz is called as subsonic or infrasonic sound. Humans cannot hear the sound of this frequency, but some animals like dog, dolphin, etc. can hear these. Uses of infrasonic sound are: it is employed in the Earth monitoring system. It is also used in the study of a mechanism of human heart. Number 3, ultrasonic sound. A sound with a frequency greater than 20,000 Hz is called as ultrasonic sound. Animals such as bats, dogs, dolphins, etc. are able to hear certain ultrasonic sound as well. Some of the uses of ultrasonic sounds are: Number 1, it is extensively used in medical applications like sonogram. The sonogram which is used to detect the fetus development. Number 2, it is used in the sonar system to detect the depth of the sea and to detect the enemy submarines. Number 3, it is also employed in dishwashers. Number 4, another important application of ultrasound is the Galton's whistle. This whistle is inaudible to the human ear, but it can be heard by the dogs. It is used to train the dogs for investigations. For the upcoming videos, we will see musical instruments, sound produced by humans, mechanism of human ear, noise pollution, cause, effects and control measures of noise pollution. If you have any doubts and suggestions, give your feedback to the WhatsApp group. Thank you. Have a nice day.